All right, next up is a tab called Result Control. The result controls, you should always have a result control that is selected, although none is required in order to do a simulation, but you should really always have one. So what is a result control? Okay, so when you get the solution to whatever is happening here, what it's going to spit out when you're done is the entire temperature field for the solution. Now, yeah, that's great. That makes for a pretty picture, but it doesn't make for a lot of really good engineering numbers most of the time. Typically what you want to know, like for example, is like just one scalar value or maybe some global value, like an average temperature rise, or maybe you want to know, I don't know, like you just want to check to make sure that energy was close to being conserved. So like how much heat flux, in this case, leaves through the bottom boundary. It should be equal to the amount of heat carried in by the laser. I believe if I did everything correctly, I designed it to be a 1 watt laser. So I'd like to check to make sure that like 1 watts actually is what was delivered. This is part of my verification process. So, like you can ask for numbers like that. So these are usually integrals, right? So like, for example, for the air, like I can click and make an area calculation that it gets during the solution process that is like the total heat flow. So like I'd like to know, like, did I actually specify like a 1 watt laser? I can integrate the heat flow over the top surface. I can create another heat flow on the bottom. So this will basically integrate the amount of heat coming out of the bottom surface. That'll help check that like the amount that went in is the amount that came out. That'll make sure that, like there's not too much leakage. And it'll also help me. So finite element codes are not guaranteed to conserve energy, but if I have like a really good set of elements, it'll come pretty close. I'd like to check that it's pretty close. So I can just check to make sure that the heat that comes in is similar to the heat that comes out. It won't be, by the way, not to like many significant digits, but I'm just want to get an idea of how close to conserving energy it was. I can, like, for example, I would like to know what is the maximum temperature in this solid. I am pretty sure that's actually going to happen at this circle, but like I could check to see like what is the maximum temperature in that solid. That would be like a thing I would want to know. In the solution fields, so by default, the only thing that the solver is going to do is solve for the temperature profile. That might not be the only thing you want to plot. So for example, I might want to visualize the heat flux lines. So if I want to do that, I need to have it do that calculation as well. That won't be done by default. If you have a good post-processing program like outside of Simscale, you can separately do that calculation. But you can have Simscale do that calculation here if you just ask for it. Similarly, if there's like some point in your if there's some point that you're particularly interested in. So for example, in this case, I'm pretty sure that I'm interested in the temperature at 0.000. That's like where I expect the temperature to be a maximum. I actually like to click, there's not really a way to like select a point because all I have is a solid model that has surfaces and volumes. But you can create a point here. So like you'll see like when I click point data, it gives me this option to create a geometric primitive. And there's a little plus sign there. So if I click plus and then create a point at x equals 0, y equals 0, z equals 0, so that's like right at the center there, I can create a point, and now it'll give me like the temperature evaluated at that point, which should be, I believe, the same as the minimum and maximum, or the maximum temperature that builds up in the solid. Okay, so that's pretty much what you do. So result controls are really most important for like the verification process that comes after you run your simulation. So think carefully ahead of time of like what makes the most sense in your simulation to, evaluate whether the simulation was done correctly.